So I'm going to walk through a few problems here. Sorry about the background noise. I am watching my 15-month-old and he's just playing in the background. So solving inequalities like this, we will want to get the letter by itself, like with algebra if we were solving with an equal sign. Same thing with an inequality, we want to get the letter by itself. So divide both sides by a negative 14 here. And anytime you divide or multiply both sides by a negative, you need to flip the sign around. So dividing on the left side by a negative, it'll just leave us with a by negative 14, and the right side would turn into a negative 3, 42 divided by negative 14. So a is any number less than or equal to negative 3. So on a number line, if you think of all the numbers, negative 3, negative 4, they keep going on and on and on forever towards, we'll say, negative infinity. And you get the positive numbers that go on and forever towards positive infinity. The answer here, a can be anything less than or equal to negative 3. So from this spot, anywhere on down towards negative infinity. To write that in interval notation, we want to write the smallest number and the largest number that a could possibly be. Well, there is no smallest number because it can go on and on as far negative as possible. So negative infinity is our smallest endpoint we're going to write down. And we always do a parentheses with infinity. Now, our largest number that a could be is negative 3. And it is possible for a to actually be equal to negative 3 because we have a can be less than or equal to negative 3. So since negative 3 is included as one of the possible numbers, we use a bracket. If instead we had started off just with a less than here, or sorry, just with a greater than, so our answer was just a less than, well, that would change to, as we still have negative infinity, and a can go all the way up to 3, or negative 3. But negative 3 is not included in the answer anymore. A has to be less than negative 3. So we use a parentheses to indicate negative 3 is the stopping spot, but we're not actually including that number. It's anything less than that. So since we had less than or equal to, this would be our correct answer. So in a nutshell, before I do the next problem, anytime we have a less than or a greater than, we're going to be using parentheses. Anytime it's less than or equal to or greater than or equal to, that's when we use brackets. And infinity or negative infinity always go with parentheses. For this problem, we want to get the variable by itself, solve the inequality, so we're going to subtract 43 from both sides. That gets the y by itself on the left, and on the right, we're going to be subtracting 43. Now, I need to get a common denominator to do this subtraction. So right here, it's 43 over 1. I'm going to need to change it to a 2, so I'm going to multiply on bottom by 2, and I'll have to multiply on top by 2 as well. So now I can actually do the subtraction, and I do not know where this equal to came from. Sorry for throwing that in there. And I'm just changing the color here because to make it easier to read so it doesn't blend in with the line above it. But 15 minus 86 is going to be negative 71 over 2. So why is any number greater than that? If you want to think of it as a decimal, that's negative 35.5, I believe. Yeah. But any number bigger than negative 35.5. I like to look at a number line to help kind of picture, it helps me picture the solution I'm going to draw. Let me draw a line here. And you don't have to fill in every number, but here's 0, here's the positive numbers, it goes up to positive infinity. Here we go down to negative infinity. And somewhere down here we hit negative 35.5. Negative 71 over 2. And so why is any number greater than that? So it can be here or anything bigger, anything greater than that. So to write my interval notation, I know my largest stopping spot is infinity. It can keep going on and on, larger and larger. I always use parentheses with infinity. The smallest number it can be is negative 71 halves, negative 71 over 2. But it can't actually be that. It has to be greater than that. That's just the stopping spot. So because I have a greater than, instead of a greater than or equal to, I use parentheses again for both sides here of this interval. One last question here, switching it up from inequalities and going to these kind of complex equal ones. We need to do as much reduction as we can on each side here with the distributive property to begin with. So take the number on the outside and multiply it by both numbers here inside the parentheses. So a negative 9 multiplied by r is negative 9r, and negative 27, and that plus 11 stays unchanged. Over here, I need to distribute as well, so I'm getting negative 99r minus 9, and then that minus 7. I'm just copying it down. Nothing, we haven't changed it at all. So now let's combine as much as we can. So negative 9r and minus 27 plus 11. That's what we can combine here is the whole numbers. I can actually do that addition there. And that would give me minus 16. And on the right side, there's only one term with r, so I can't change that. But I can, again, combine our actual numbers. And if you're negative 9 and you minus 7, you're now be negative 16. All right, so now I can add 16 to both sides. I'm trying to just combine my numbers. And it actually, since there's a negative 16 on both sides, that's going to cancel. It's going to cancel out the whole number part on both sides. So now we're just left with terms with the variable. And so let's go ahead and divide both sides. Let's add negative 9r to both sides to try to get all the r's together on one side. So here it's going to be 0 because I'm adding 9r. And here if I add 9r, that's going to leave me with negative 90r. And so now divide both sides by negative 90 to get r by itself. And this will be our solution here. Well, 0 divided by anything stays 0, so r is equal to 0.